Since this is new findings under climate change, climate science, and climate solutions, I'm just going to keep including things that I find interesting. One of the menaces that is trying to be dealt with is the mosquitoes. Mosquitoes went from Africa to the rest of the tropics, but now with global warming, their distribution is increasing in latitude as well as altitude, and there are ways in which mosquito populations are being attempted to be controlled, or also ways in which they can reduce disease transmission. So, for example, this world mosquito program infects mosquitoes with the so-called Wolbachia bacteria, which is quite common, but are not carried by mosquitoes, and they are harmless to humans. So when mosquitoes are infected with Wolbachia bacteria, they compete with the viruses that are breeding in mosquitoes. Mosquitoes bite one person or an animal and pick up some viruses, and they play host to the virus often, and they transmit it when they bite another person or another animal. So infecting mosquitoes with Wolbachia has been already tried. Wolbachia infested mosquitoes have already been released in Indonesia, Malaysia, and I think Australia, and they have shown that there was demonstrable decrease in the spread of dengue. So diseases carried by mosquitoes like dengue, malaria, chikungunya, West Nile virus, Zika virus, etc., all are becoming more and more prevalent with warming, more humid conditions, vegetation changes, urbanization, and so on and so forth. And there is already projections made as well with comparisons of past mosquito populations in terms of life cycles completed within a year. So we are looking here at the annual cycle and different bands of latitudes, 30 to 40 north, which is already pushing towards the edge of the tropics, and you can see that the past 1950s, 2000s are down here in terms of the number of life cycles completed, which is basically one or less, but with future warmings under different scenarios, like the representative concentration pathway 4.5, which is the middle of the scenario, and RCP 8.5, which is the business as usual scenario with maximum emissions and maximum warming. Both end up increasing the number of life cycles within a year, of course in the warmest part of the year in the northern hemisphere. When you come down to 20 to 30 north, numbers are a little bit lower because of the combination of these are basically desert regions, so vegetation, humidity, rainfall, population, etc. together provide habitats for mosquitoes. So, but still, the message is that in the future you can expect throughout the year number of life cycles completed to increase. Of course, much worse for 10 to 20 north. The rain band, typically you can think of it as the global monsoon band as well, and you can see a significant width of the band there around the median value in terms of the 95th percentile confidence intervals. And in the tropics it's highest, so already you have more than one life cycle completed for the 1950s, which has increased already to the 2000s clearly, and is going to increase further with RCP 4.5 and RCP 8.5 for 2050 to 2054 period. Okay, all of them are for that period. In the southern hemisphere, obviously much more ocean than land, but Zika, if you remember, exploded in Brazil, so there is a large chunk of the Amazon and Central African forests, which are south of the equator and can host lots of mosquitoes as well. So the summer season there is of course in the opposite period of the year, so December, January, February, where life cycle completions in the 30 to 40 north don't show as much of an increase compared to the northern hemisphere because of this asymmetry in continents and population and rainfall and so on. 20 to 30 south again shows an increase in the hemispheric summer, austral summer, and 10 to 20 south, there has been a slight increase from the 1950s to 2000s, and there is a remarkable jump in the number of life cycles completed in the summer months. And of course, tropics, again, similar to the northern hemisphere, have multiple life cycles completed already in natural. Let's say if 1950s was minimal in terms of human impact on the climate and warming, so you can think of that as, let's say, natural variability. By 2000s, the impact of humans is obvious in terms of increased life cycle completions, and for future scenarios it's expected to increase as well. Okay, so US is now given permission to release millions of genetically engineered mosquitoes in California and Texas and so on. So Aedes aegypti populations can be repressed by genetically altered mosquitoes. The modified mosquitoes are non-biting males carrying a manipulated gene that, after mating, kills the insect's offspring. So female mosquitoes bite and transmit diseases. So if you get the genetically modified males introduced into the population, they mate with the females and sterilize the female, and reducing the mosquito population. Okay, so this is from the mashed up, whatever it is called, Mashable journal. So here is the order issued by, I think, CDC. Florida, California, total during 2022 to 2023. Florida, California during 2023 to 2024. Overall permits issued around 35,000. Number of mosquitoes here, 2,445,040,000. That's a massive number, but remember that by just allometric scaling, smaller species have much more biomass. So small body mass, larger biomass. In other words, the biomass of all the mosquitoes will be higher than the biomass of all the humans or the elephants. So that's the way it works. So 2 billion is not that large when you consider mosquitoes. And pounds of active ingredients in the mosquitoes is 0.022, so 10.06 gram, which is a measure of how potent is the genetically modified material that is being released. So enzymes we looked at for degrading plastics. There is already been bacteria degrading oil spills consuming hydrocarbons. There's going to be all kinds of biotechnology, bio-inspired catalysts for sequestering carbon or converting CO2 into methane and carbon monoxide and synthetic fuels and so on. Genetically modified mosquitoes is one thing. Of course, there are genetically modified crops already out there. Debate continues about whether GMO crops are good for us, bad for us, safe for us, not safe for us. But that ship has already sailed, in the sense there are plenty of genetically modified crops already in the system. So genetically modified mosquitoes are now part of the system as well. Wolbachia infected mosquitoes have been released in the wild in Indonesia, in population centers, not just wild, in Asia and Australia. So these experiments will continue, and data will continue to come in as to how well they work and whether they have any unintended consequences. Okay, Wolbachia is harmless to humans, and genetically modified male mosquito doesn't bite. So those are kind of used as ways to say they are safe experiments. So hopefully there is no Frankenstein aspect to this, but these are the kind of solutions one can expect to become more and more common. Okay,